In this segment and the next several, we'll look at the Code Worlds class, which ties together all the other code we've looked at into a full application. And along the way, we'll review some Java basics and look at input streams, for instance, as an example of object-oriented design. Now, most of the Code Worlds class, right up here on screen, is devoted to setting up the initial configuration of animals and trees and so forth based on a text input file or typed text input. Here's an example of the Code Worlds input format just for reference. The first line gives the number of columns and then rows in the grid, and then the maximum range of x values and of y values that need to fit within that grid, and then the margin for the margin vector class. And then after that, the remaining lines list entities in the simulation, and they give the entity type, like cow, ID number, the x and y location, and then the x and y coordinates for its velocity. In cases where there is no velocity, for instance a tree, we just have the location. Now returning to the code here, we can see that the init config static member class, inner class, contains all the information read from the input file. And question 1. Most of init config is self-explanatory, but why are all the entities in a list of objects instead of a list of animals? And the fairly direct answer when you think about it is, well, not every entity is an animal, right? There are trees, and we'll have other things as we add new classes later on, so we would need that generic list of object. Okay, so let's go down now and look at the main function. Now, this one expects command line arguments. And understanding command line arguments is prerequisite material, but here's a very fast review. When you run a program at the command line, let's say you run something like Code Worlds, and then add a couple of more arguments after it, the G and input 1 are command line arguments. And they show up in a Java program as elements of the string args array that is passed to main. If you're a C programmer, by the way, note that the Code Worlds command itself is not included in the command line arguments. It's not passed. So there would be only 2 command line arguments in this example. Those 2 right there, G and input 1. Now, if you're using an IDE instead of the command line, the IDE will supply a means of setting command line arguments. In Eclipse, for instance, this is done in the Run Configurations dialog, which you can bring up briefly here. In the configuration for Code Worlds, for instance, you can put the command line arguments under arguments there. And your IDE, if it's different, will have a means of doing this. You just need to figure it out in order to run Code Worlds. Now, question 2. Read the code here at the start of main and tell me how many command line arguments, the minimum and maximum number, are allowed, and what must they be, according to the if tests there. And after reading that for a bit, the requirement is that there be 1 or 2 arguments, as you can tell right there. And the first must be either G or D. And then the second, if it is provided, is a name of a input file of some sort. Now, if the command line arguments don't follow those rules, main throws a CWS exception. Don't worry about the exception handling in the code just yet. We'll talk about that a lot in the next segments. But if the arguments do pass, then main calls getInitConfig. And it passes it an input stream, which can either be from a file if there is a args1 if the second command line argument was supplied, or system.in reading from the keyboard. But that needs a little bit of discussion. So first of all, wait a second here, get initconfig takes an input stream, right? But that's clear enough from its header. But down in at least one case in the main, we're passing a file input stream, which is declared in the variable file likewise as a file input to stream. So isn't that a type mismatch of some sort? And to answer, you want to figure out what an input stream is, and look at the java.io package will help a good bit. And read the docs is the main message here. Okay, returning from a bit of a pause there. You can see in the docs that input stream is an abstract class. Not an interface, by the way. And it has subclasses that manage streams or sequences of input bytes. An input stream of bytes, as that's termed. File input class, or file input stream, sorry, right there, is a subclass of input stream. So file input stream is a input stream. And there's no type mismatch. This is yet another example of a base class that represents an abstract behavior, that of getting a sequence of bytes from some source. A typical source of input bytes is a file, and the input stream subclass, file input stream, is constructed, as you can see back in the code here, is constructed with a file name. And it gets its bytes from that file. But the byte source might instead be a network connection, or an audio input, or what have you. Each possible different source is represented by a class derived from input stream. Input stream uses the template method design pattern. It provides basic code for managing streams of input bytes and provides an abstract method for getting the bytes from their source, and that abstract method is overridden by its various subclasses to get bytes in whatever way they're supposed to. And not too surprising, I'm going to ask you, what abstract method is that? You can tell it from the Java docs, so go look again at the docs and tell me what abstract method is the template method in input stream. Okay, and after a bit of thought, well, if you look down here, the read method, the one without parameters, is declared abstract. So this one is supposed to get the next byte from whatever input source is supplying them. It's abstract, as the docs indicate, so you could build your own input stream subclass by overriding that method. And you may be doing so in the LMQs, as a matter of fact. So what subclass of input stream would get bytes from an audio source, like a microphone? And what about one that gets its input bytes, quote unquote, from an existing array of bytes, as if the array were a data file? Again, check the docs. They're all there. And after a read of the documents, well, it would look like audio input stream would be the one that gets from a audio source, and byte array input stream apparently reads from a array of bytes. So returning to the code world source here, what about the alternative that we passed, system.in? I would guess that the in member of the system object refers to a simple input stream object, right? It's certainly declared that way, right here in the Java docs for system. And it's an input stream. So my question then is no, in fact. What I just said is wrong on 2 counts. So find both lies and look up the docs for system right here that I'm showing you. You can find it in the java.lang package. And then also think carefully about what we just said regarding input stream. So why then is it wrong to say that system.in is at least a member of the system object and refers to a simple input stream? Well, it's wrong, first of all, because system isn't an object, it's a class. And in doesn't refer to an input stream. First, system, being a class, means that in is a static member of the system class. It represents the standard input, and that's usually just your keyboard. While in is declared as an input stream reference, we just discussed the fact that input stream is an abstract class, so there will never be any input stream objects. Whatever type system.in refers to, we know only that it's a subclass of input stream, and it's suitable for reading from the keyboard. It may thus be treated like any other input stream subclass by calling input stream methods on it polymorphically. There is also, by the way, an output stream abstract base class right there. And this has a design very similar to that of input stream, but output stream's subclasses write byte sequences to some target location, whether it be a file, an array of bytes, or whatever. And system, by the way, does have two static members, air and out, that write to the standard output and the standard error, respectively. And both of those are normally your screen, though either may be redirected to a file if you run the program on the command line. In the next two segments, we'll talk some about Java exception handling from an object-oriented standpoint.